Okay, I'll just check you guys can hear all right. You guys okay? You want more? A bit more power. Okay. How's that? Is that better? That's good? Okay. And what about you guys in the back? You okay? Okay for sound? That's a nod, I think. It's kind of hard to tell. You guys okay for sound? Good? Turn up a bit. How's that? Is that better? Okay, and you guys in the middle, I presume, okay? Right. Okay, so, yeah, that thing, tell what thing is that? Okay, I think it's gone forward. It's kind of hard to tell at this angle, but anyway. Okay. So we'll make a start. We're in the topic of the level of interest rates, and the previous topic we looked at how the central bank sets the interest rates in one particular market. And in this section, we're looking at how interest rates get set pretty much throughout the rest of the economy. So what we sort of said, it's just like with any particular market, we can think of it in terms of a supply and a demand. And in this case, the quantity of the thing being supplied is dollars, and our price is an interest rate. And so we drew the demand, it's often called demand curve, as a straight line going down. Basically, probably a better way to think of it is the higher the interest rate, the less likely there is to be some demand for borrowing, simply because it becomes more expensive and ultimately becomes too expensive and people stop borrowing. On the other side, in terms of supply, we tend to draw it up, and the way to understand that is that as the interest rate rises, the incentive to save and invest goes up, and so you tend to see the supply increasing. And for that one there, the supply, sometimes if you're a large issuer, you can actually see that in a competitive bond bid, like we were talking last week. In, say, a large government bond issue, they're often oversubscribed, anywhere from like 2 to 4 times as much money is offered as is on issue. And what they do is simply rank them from the lowest interest rate, which is the cheapest for the government, up to the most highest interest rate. And they definitely see a clear increasing trend as, you know, the interest rate goes up. There is certainly more supply there. And so between those two things, there is some quantity and some interest rate where everything is in balance. And at that point, we say that the market is in equilibrium, although anything that will change either the supply line or the demand line will change the interest rate, and that still, even though it's changed, is called an equilibrium. So all markets work like that. All interest rate markets work like that, where there's some sort of competition. But what we're looking at is what considerations go into deciding, you know, whether you're going to, if you have money to invest, what factors go into deciding how much interest do you actually want before you're actually going to go ahead and invest. And on the other side, the demand side, basically it's asking the question, what am I willing to pay? And there's some upper limit to that. And there's various factors that go into consideration there. Probably the first one is what we call the real rate. And for a saver, the real rate is how much extra purchasing power do I want to gain by investing my money. So that's a key feature of the investment side. Second thing we talked about was inflation, because inflation will erode the purchasing power of the money that you have invested, and also erodes purchasing power of the interest that you earn. And so you want to be compensated for the inflation that you expect to occur. And we showed that graph last week. Unfortunately, I didn't bring it with me today, which shows over the last 8 centuries, in the last 100 years or so, because of the change in the way that money is made, inflation is a much more serious issue now than it had been in the previous 700 years. And then collectively, there's a whole bunch of risks that you need to take account of. And basically, every time you see a risk, you need to work out in some sort of statistical sense, what is your expected loss from this risk? And then, because you have that risk that you might have that loss, then you actually add that on to your interest rate to compensate you for the risk that you're taking. So then we looked at just a few ways of thinking about an interest rate. One way to think about it, it's a rental. It's a rental. So if you're going to rent someone else's money so you can get its purchasing power, then interest is the rent that you pay. One way to look at it is that because borrowers are actually consuming before they've earned, it's a penalty to them. They have to pay extra for that purchasing power that if they had waited and earned it, they wouldn't have to pay. And of course, for the saver, it's an incentive. So it's a reward for deferring your consumption into the future. And the final thing we sort of really talked about was, as a price, it serves this allocated function within the economy. Remember back to our first section, we talked about our wish list for what we would like our markets to be like, and what we would like them to be is allocationally efficient. And so because the interest rate is actually a price, it serves to allocate capital, and we hope that the things work in such a way that the capital gets allocated to those projects which will bring the most value in. And that brings us to this section here, so we'll move on. Fisher effect and Fisher equation. So, anyone met the Fisher equation before? Anyone met it in another course and know what it is and why we use it? All looks very quiet today. The Fisher equation is basically trying to deal with the fact that in the world we live in, inflation is an inevitability. So the Fisher equation tries to take account of that by simply taking two things. One is your real rate of return, and the other is this expected inflation. And the equation looks like this. So it's 1 plus I, and this thing here, this is the nominal interest rate. And if you went out into a market and looked at the interest rate, that's the one you see. So if you're asking yourself, well, how much do I want myself if I'm going to go and invest? There's two things you need to consider. One is the real rate, and this is real rate. That is your growth in purchasing power that you want. That's what you want to do. The reason you're saving is you want to grow your purchasing power. The other thing that you have to take account of, and this is quite a simple model, is you have to take account of inflation. And we write it delta PE, and that there is expected inflation. Because what you're doing as an investor, and all investment is like this, is you're making some forecast about the future, and then you act upon that forecast. And so what you have to do in terms of the interest rate is you have to somehow make a forecast of what you expect inflation to be over the time of your investment, and then you factor that in. And so in a very simple sense, those two things, the real rate and the inflation rate, are the two things that are taken care of in the Fisher equation. Now, issues around risk and risk factors and stuff don't come into this particular equation, but we can certainly take care of them later. Now, the thing about this is that you can actually multiply this out, and you can actually see that, even though we've only put two factors into this equation, we actually come out with three different things that we're actually being compensated for in our interest rate. So if we solve for this, multiply this out, solve for this interest rate here, this interest rate is the R, that's your real rate there, plus the expected inflation, and then, of course, when you multiply the R with the delta PE, you actually get this term here. Now, it's kind of obvious what they are. The real rate, that's that one there. Delta PE is the expected inflation. But what's the financial meaning of that term there? We've got a third term in there that we didn't start with when we just did our maths. We come out with this third term. What is the financial meaning of that third term? Yeah, go ahead. Well, it's not the interest loss of inflation. It's the loss of purchasing power of the real part of it. Okay. So when you're thinking about them, if say you want 3%, and return, say you put $1,000 in and you want 3% of that, and at the end they pay you $30 for the rental money or the real return. If there's been inflation, that $30 will have lost some value. If you were asking for 4%, it would be $40, but that would have lost some value. And this final term here, the R times the delta PE, is the one that compensates you for the loss of the purchasing power on the portion of it that's actually your real return. So if you just got, your real return plus your inflation, you'd be actually not getting the return that you expected because you have some loss on your real return. I expect you actually meant that. But, yeah. So that's what it's there for. And one of the things, this is not a very mathematical course, but one of the things we can do when we do mathematics is that sometimes it yields insights that we probably would not have found any other way, or would at least been very difficult to find. This is quite simple. This is a simple product here. But we only had 2 terms in here, and we've ended up with a third one, which has a very clear financial meaning. And so by actually multiplying that out, we actually have seen something that we probably wouldn't have seen if we just stuck with this equation up here. Now, next question there. If actual inflation turns out to be less than expected inflation, would you rather be a borrower or a lender? Okay? If actual inflation is less than what you expected, so inflation is less than what you expected, is that good for the borrower or good for the lender? Go ahead. Yeah, why is that?
Because if you're borrowing, inflation will erode the real value of the principal that you're borrowing.
Yeah, but it's ended up less than was, exactly. And so you end up with one that's more. Yeah, so that's what's happened. If the inflation, because you have to make this forecast, and of course, forecasts aren't particularly reliable, unfortunately. But if it turns out that the actual inflation is less, then you actually, as an investor, will earn more than you expected. And that's a good thing. So that's an important thing to remember because, we set these interest rates by looking into the future and making forecasts, but those forecasts are not necessarily reliable, and at the end we may have earned more than we expected, or we may have earned less than expected. So moving on, said that one. There's the thing. Okay, so the question down the bottom, under what circumstances would the Fisher equation actually predict a negative interest rate? We've seen negative interest rates on rare occasions. They do exist. If we were just taking the Fisher equation at its face value, when would it predict that the actual nominal interest rate would be negative? What do you think? You don't think? No idea? No idea. Do you have any idea? When would it predict negative interest rate? Yeah, it has to be negative, but it has to be sufficiently negative. Like, for example, take an example. If you say your real rate is 3, it has to be more negative than 3. So if it was minus 3.5, then you would predict, at least from this equation, you would predict a negative interest rate. So in theory, you can get negative interest rates if there's enough deflation. And basically, the deflation has to be more than the real rate you want. So if your real rate's 3, then you could get a nominal rate that's less than 0 if the expected deflation was more than 3% deflation. So we do see negative interest rates, and we've seen them quite recently. I'm not sure if this is the actual explanation, but you could explain it in terms of deflation. So we talked a little bit about this unexpected, unanticipated inflation. Sometimes it can be more than we expect, sometimes it can be less. If we get more than we expected, that reduces the purchasing power of those funds, and that benefits the borrower, because the borrower basically gets to pay the money back although they're still dollars, they are dollars with less purchasing power than he had expected to use to pay it back. So let's do a calculation. Here's a problem to work. Okay, so let me switch to this one. Right. So, okay, so here's this contract. Okay, you got a 1-year $1,000 loan. Parties agree on a 3% rental rate for the money and a 5% expected rate of inflation. So looking forward, and they see 5% in the next year. So what nominal rate do we need to deal with both those factors? What's our nominal rate on those? How would we calculate the nominal rate that we want to deal with this? Follow the formula. Good start. So we'll put the formula down. We can write it 1 plus I is equal to 1 plus R times 1 plus delta PE. So what's R in this case? 3%. And it's not showing up very well, but anyway, what if I turn the light off? When you do this calculation, you have to convert these things to a decimal. So 3% as a decimal is 0.03. Okay, so you're going to have to convert it to a decimal and make sure you know how to convert from a percentage to a decimal and back the other way. And what are we going to use for our expected inflation? Yeah, 0.05. So 1 plus the nominal rate is going to be 1.03 times 1.05, and that equals 1.0815. So the interest rate as a decimal, 0.0815, expressed as a percentage, 8.15%. That would be our nominal rate that we would be wanting. So if we wanted real return of 3%, we looked into the future, however we do our forecast and we see 5% inflation, then we want 8.15% as a bare minimum. Anything more than that would be great. That's the bare minimum that we would want if we're investing. So let's say they make a single payment. So it's got $1,000 invested at the end, and so we multiply these things out times the 1.0, this number here, 0815, and that means that at the end, if there's a single payment at the end, we'll get $1,081.50. That's what we'll get. So of that $1,081.50, how much of that is actually for the rental power, renting of our purchasing power? Go ahead. 3%, which in this case is $30. So if we're breaking that down, our rental, or the real return, is supposed to be, of that, will be $30. Okay, second piece is there's an amount paid to compensate for loss of purchasing power on the principal. How much of this $1,000, 81.5, is actually for the loss of the purchasing power of the principal? $50. Yeah, so it's 5% of the 1,000, and so loss of on the principal. Oh, yeah. So that's going to be $80. Now, last one there, the amount paid to compensate for loss of the purchasing power on the rental. So if you think of the $1,000 that we put in, where's my $1,000 here? This $30 is the rental money. This $80, that's 50. That 50 is for the loss of the purchasing power on that 1,000 there. So the final one, the amount paid to compensate for loss of purchasing power on the rental, is basically loss of purchasing power on this $30 here. So how much of that $1,081.50 is to compensate you for the loss of the purchasing power on that $30 rental? $1.50. Yeah, it's that last little bit. So loss of purchasing power on rental is equal to $1.50. And adding those up, you actually got, $81.50 in interest, and that's how it's split out. $30 there is to compensate you for loss of the purchasing power on the money you invested. That's your $1,000. Your $30 is the rental money. That's the rental money you want for that $1,000. So they borrowed your $1,000 for a year. Essentially, they've rented it for $30. The $50 is to compensate you for inflation, and so that's the loss of the purchasing power on that $1,000. And then, of course, this little bit down the bottom here is that this $30 itself has lost some value because of the inflation. And so the $1.50 extra is to compensate you for the fact that the particular lot of $30 there has lost some purchasing power. So put it together, all together, you get $81.50 interest on this investment. Any questions on that? All clear? No? Okay, moving on. So there's the numbers. Now, it's important to ring it. It's not the observed inflation rate. You have to forecast this stuff. And normally, because the Reserve Bank has this target, 1 to 3%, you can average over long periods of time if necessary. And that nominal interest rate, that's the one you actually see in the market. You only actually see one, but we can split it out into various pieces. But the interest rate that you see in the market is the nominal rate. It incorporates everything. And if there are risk of premiums, they'll be in there as well. Oops. So here's a question. Let's begin. So here's a question on the side over here. So the one-year rental rate in this case is going to be 5%, and this current annual rate of inflation is 2%, and the market forecasts that the annual rate is going to be 4% over next year. So we want to calculate a single one-year interest rate. From this data here, how are we going to do that? Oh, good idea. Start with the formula, 1 plus I, 1 plus R, 1 plus delta PE. And in this case, the R is what? Yeah, 5%. And so converting into decimal, 0.05. Which one of those? You've got two inflation figures there. Which one are you going to use? 4%. Why do you use 4%? Yeah. You're looking forward. The fact that you got 2% behind you is not useful to you in calculating what you need. You look forward, you see 4%, however you make your forecast, and so that becomes the one that goes in the formula. So 1 plus I is equal to 1.05 times 1.04, and shop there. That's 1.092, and so the interest rate, if we convert it back to a percent, is 9.2%. So that's how you would calculate it for 1 year one. Any questions on that one? Okay, people happy? What about this one here? This is a 5-year investment. So we're going to do 5 years this time. And down the bottom here, we wanted a 3% real rate over this 5-year period. But here's our forecast for our inflation. How are we going to deal with the fact that we've got multiple years here? Go ahead. Okay, and how would you take that average? And multiply and divide by 5, that's known as an arithmetic average. Does anybody think that's a good idea or a bad idea, or most people don't know? How many think it's a good idea to take, add them all up, divide by 5, that's your average? You got one guy on your side. How many think that that's a bad idea? Oh, you're winning. Okay, how many people don't know? Oh, 2 people. Oh, all right. Okay, it was 2 to 2. In actual fact, what you have to do is take the geometric average. Okay. With these small numbers, it makes very little difference if you take an arithmetic average. But in reality, what you should do is you should take a geometric average. And so to do that, what you would have to do is 1 plus I. Now, this is the nominal interest rate here that you want. Because over 5 years, and let's assume that we're only going to compound it once per year, you're going to have to take that to the 5th power. So it's compounded every year. And then your real rate is the 1.03. And again, you want that every year for 5 years. But then you have variable forecasts for your interest rates. And this is where I ask the question, how do we average these things? We basically have to multiply them together. So we have an expected inflation in the first year, multiply that by the inflation in the second year, through to the last one in the 5th year. So these ones here, we've got the numbers there. So that's 1.03. That's your real rate there to the 5th power. 1.02 in your first year. And then we look at this here. In years 2 and 3, you have the same inflation rate. And again, in years 3 and 4. So we can actually combine them. So we'll put the 1.03 for that inflation squared, because we've got 2 of those over that period of time, and again, a 4% in those 2 years, years 3 and 4, square that. And then what we then do is we multiply that out. Now, that will, if we do all that, okay, 5th power, that's 1.02, 1.03 squared, and I can actually combine these 2 terms here if you really want to, make it the 7th power. That comes to 1.35, 684. Now, at this point, you see we've got the 5th power up here. So to get the I, we've got to take the 5th root to the 1/5 power there, and that comes out at 1.0629, and of course the final interest rate there is 6.29%. So although in this case it makes very, very little difference if you take an arithmetic average, to do it properly you need to take a geometric average, and you need to take account of the fact that stuff is compounded. Okay. Are there any questions on that? How we do it? Why we do it? Okay. Anybody have? Okay. Sorry. So there's a second one down there. If you change the inflation rate from 2% to 4%, what do you get? I did do that. Where did I put it? If you do that one, I'm pretty sure off the top of my head it's 6.71%. So you can try that one on your own and see if you can get that number, 6.71% for that one. So that's just by changing the first year from a 2% to a 4%. Okay. So now, once you get to the end of your investment and you're looking back, you often ask yourself, well, how well did I do? Because when you start, you have an expectation of what you're going to get in terms of your return. But of course, at the end, you know everything about your investment. You know if there are any defaults and all that sort of stuff. You know how much you got paid. You know what actual inflation was, and you can work out what your return was. So there's your nominal rate there that you calculated at the start, that you got, that was set. And this one here, delta P, with the subscript A. A is for actual. And at this point here, at the end of your investment, you can actually work out what your rate of return was. Because at the beginning, you can forecast it. At the end, you know what's happened, and you can work out exactly what you got. So if actual inflation was higher at the end of the loan than expected inflation at the beginning, the lender is going to have a lower realized rate of return. That's bad for them. So that's why in this particular case, if the inflation rate is higher than you expected, it would have been better off as a borrower. And what that really means is because You calculated at the start how to make it fair. It's ended up a little bit unfair, and that there has been some purchasing power transferred over to the borrower that you never intended to happen. And they get that extra purchasing power at your expense if the inflation turns out to be higher than you expected it to be at the beginning. So before we go to the graph, anyone want to ask questions, make a comment on? Everybody's happy? Or quiet? Or both? Okay, so this is the some Australian data. The bluey line there, that's their 3-month Treasury bill. And then after you take out the inflation, the grey line is the actual realized rate of return. So that's basically the actual nominal rate minus the inflation rate. And you can see it's quite low. Basically, the gap between them, say that gap there, that was the inflation that occurred at that period of time. And you can see that there's only there's actually a point here where inflation got negative. But throughout this entire period, there's actually been a positive rate of return on these 3-month Treasury bills, although there are certainly like times here and here when you've only just barely squeaked into the positive territory. Which is actually a little bit unusual. Most countries you look at, you'll find that these Treasury bills at times will give you negative real returns, even though, of course, the nominal rate is always positive. Okay, now, what about this question here? It says, if the realized rate of return turns out to be positive, would you rather have been a borrower or lender? Realized rate of return is positive. Lender. How many people think it would be good to be a lender? And the other option is to be a borrower. How many people think it's borrower? One, two. Right. Okay. In actual fact, this is the wrong question to ask. Okay. So really, I mean, I understand why people vote the way they do, but a question like that actually asks the wrong question. So if we're thinking about, go back to the Fisher equation. There's one. Here's one here up the top. Is that this is what we wanted, real rate of return here, this R. And we assume this is positive. Let's say it's like 3% or something, 3%, 4% something. That's positive. And just because you get a positive return doesn't mean that you've actually got what you wanted. So the question you should really be asking, and this one's actually out of the book, is how did you fare compared to what you expected? So if you say you wanted 3% real return, and at the end you got 4, you actually got more than you expected. If you wanted to get 3 and you calculated things on your expectation to get 3% real return, you ended up with 2, you get less than what you expected. So whether it's actually better to be a borrower or a lender depends on relative to the real rate of return that you wanted at the start. Because the person who borrows, they actually expect to pay a real rate of return. And so the question for them is, they actually, if you set it at 3%, they expect to pay a real rate of return of 3% to you. But if they got it at 2%, then they actually got it cheaper. If they had to pay 4%, they had to pay more than they expected. So both the borrower and the lender expect to have in terms of lender, earn a real rate of return, positive. The borrower expects to pay a positive rate of return. And his question is, where are you relative to that real rate of return, not whether that's positive, negative in the absolute sense. Okay. Any question on that before we move on? Raise it. Right. Okay, here's another one. Can we explain the Fisher effect in terms of the loanable funds theory? So let's draw, do we think we can do it? Can we explain Fisher effects in terms of the loanable funds theory? Or was this a lost cause? Nobody has any idea. What's that? Possibly. Oh, well, it's ambiguous. Okay. So let's start off here. So this is our quantity in this case. That's our dollars. There's our interest rate up there. And let's say, because this is the Fisher effect, here's our supply, and here's our demand. And instead of being interest rate at time 0, we're going to make it actually the real rate, because this is how the Fisher equation starts with. So if you looked into your forecast, however you do your forecast, and you're a borrower, and you see, inflation is going to be up, it's going to go up, would you be more likely or less likely to borrow if you saw inflation going to be high in the future? Would that make you more likely or less likely to borrow? If you more likely, and what's that going to do to demand? You're going to pay less back, but you're more likely to borrow, so that shifts your demand over. Okay. If a whole bunch of borrowers see inflation rising, they are likely to try to borrow more. Now, if you're a saver and you look into your forecast, however that forecast is made, and you think, oh my gosh, inflation is going to go up, would you be more likely to save or more likely to spend it now? Think of what inflation does to your purchasing power. Were you more likely to save it or less, or more likely to spend it? More likely to spend. Is that somebody over here with a spend? Yeah, and so if you spend it, that means you're going to reduce the supply. So here your supply line is going to shift in this direction, because you see inflation going to take your purchasing power away, so that, well, I might as well spend it now while I've got it before it goes away. And so the supply line, hopefully I'll drive this the right place, will shift over this way. So this is our supply at time 1. Now if I've drawn this right, our quantity is now unchanged. Quantity is unchanged, but the interest rate is now up here. And that's going to be 1 plus this R, which is down here, plus 1, times the 1 plus the expected inflation. So in a very general sense, just thinking about how people would respond to an increased inflation or forecast increase in inflation, we can explain the basics of the Fisher effect in terms of the loanable fund theory. Because inflation, if you expect inflation to rise, borrowers are likely to try to borrow more because it becomes cheaper. But it's also a disincentive to save because you lose purchasing power. And between the two, the quantity might well be unchanged, but the interest rate rises. Okay, any questions on that before we move on? Sorry, was it you or was that somebody else? That was you. Go ahead. Okay, so at the start, the D0 and the S0, okay, they're at balance at some point, and the R is the real rate. Okay, so that's because we're working with the Fisher equation. There's two things in there. There's the real rate, and then there's the expected inflation. So that's where we start with the real rate, with no inflation. Now, if we expect that the inflation is going to be higher in the future, or we're going to get some inflation, if you're a borrower, that's good for you because you get to pay that money back with dollars that have lost some purchasing power. In a sense, it becomes cheaper for you. So if you look in the future and you see inflation coming up, that means that you're more likely to borrow because you can pay back with cheaper dollars. Now, if you're a saver, you have the opposite problem. Inflation is going to take away your purchasing power. So you think, what should I do? Well, it says, I should spend it now rather than save it. And so that tends to shift the supply down. So the supply drops away. So in one case, demand goes up because you get to pay back in cheaper dollars. The other one, supply goes down because you spend it now rather than saving it. And of course, between the two of the things, when you shift both those lines, you end up with a higher interest rate. Does that make sense? All right. Now, do you have another question?
Yeah, I'm just wondering that this loanable funds theory, what's the relationship that if you get one and the invisible hand theory?
Oh, any invisible hands? Invisible hands, that's just a metaphor. Unfortunately, it's just yeah. I mean,
Apparently, this theory is based on that one.
yeah, it is. It's basically the supply and demand gets these things into balance. That's all. That's all learnable funds theory is about. It's taking the basic theory about supply and demand, and you get equilibrium and a price. It's simply applied to this interest rate market. That's all that is. Okay. Any other questions? Invisible hands, oh, magical stuff. Very magical stuff. Okay, so explanation there. So there's a thing. Okay, what about forecasting? Why if we were investors or borrowers or whatever, why would forecasting interest rates be important to us? All very quiet, all very quiet. Okay, so basically, there's several reasons. If you're a business, borrowing money is a cost to you, and if you can figure out what the costs are going to do in the future, you can decide, when to borrow. So if you think that interest rates are going to go up in the future, you want to borrow now. If you think they're going to go down, you want to delay your borrowing. So being able to forecast would help you manage your business well. Plenty of other things, like if you're an investor in fixed income securities, changes in interest rates will affect the value of those. And if you can forecast the changes of the values, like for example, if you think that the value of securities may drop, you can sell them before they drop. If you think they're going to rise, you simply hang on to them. If you've got money, go and borrow some more. But the thing is that once deregulation occurred, which was now 40 years ago, or even more than that, interest rates have become volatile and they tend to move around a lot. And of course, that directly affects the value of things. And basically, if we could forecast them, it would certainly help us whether we're an investor or we're a borrower. Either way, whichever boat we're in, if we could forecast, it would certainly help us do our job better. Now, economic models is one way of doing it. Basically, the idea there is that you have some statistical relationship between some variables which you think cause the interest rates to change. You set up a model, and then you estimate it, and then when you get new data, you plug it into one side of it, and then forecast comes out the other side. The key assumption there is that the causality among the variables is stable, which of course may not be true. But it's basically an exercise in statistics. You gather data, you estimate a relationship. When you get new data, you plug it into the formula you just developed, you get a forecast out. And they can be anything from very simple models, just single equations, up to extremely complicated ones. And there are reserve banks of the world that I think the Bank of England, the single one, I think it's our one, Reserve Bank of New Zealand, at one stage was using an 800 equation model. Okay, so lots of stuff to estimate, lots of equations, but it's basically the same. They estimate it, and then when they get new data, they plug it into their equations, and a forecast comes out. Whether you do it by one equation or 800, the principle is the same, that you assume that whatever the statistical relationship between these variables is, that simply continues as it has in the past. Now, the flow of funds accounting, I might even take this out next year because this is really complicated. In fact, if you go to the U.S. Federal Reserve website and you look up the flow of funds accounting data, it's just masses and masses of stuff. Vast amounts of data. But what people do, if they use that method, is that they're looking at all sorts of different sectors of the economy, because when we're thinking about these markets, say if we look at, a market like whatever that one is, many of the markets are reasonably segmented. There's reasonable segmentation, so there's not a lot of overlap between the investors in one market and the investors in another market. And if you get, potentially excess demand that can't be met in a particular market, then you might forecast interest rates to rise basically on simple supply and demand. But this stuff is really complicated, this flow of some stuff. Anyway, how good are they? How good are forecasters? How good are they? Not very good at all. Bad, 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 bad. Yeah, they're terrible. They're just terrible bad. Not only is bad, but this point here is an interesting one. They are getting worse over time. In fact, I read a paper from the Reserve Bank of Australia trying to explain why it is that they're getting worse, but they definitely said they're getting worse. Now, why might them getting worse actually be a good thing? Why that might be a good thing? If they're actually getting worse, and they're definitely getting worse, why might that actually be a good thing? Go ahead. Less likely to rely on it. Okay. How does that help you?
Well, if everyone thinks it's going to go one way,
Yeah.
then they all go that way.
Yeah.
Then it's not that way.
Okay, so you think like you might get rid of the herd mentality?
Yeah.
That's a good point. I never thought of that one. Good point. They might get rid of the herd mentality. Okay. That's an interesting point. Okay. Any other reason why you might think this is, why do you think they're getting worse? Why do you think this actually might actually be good for us that they're getting worse? Don't know? Okay. You have to think back. Right back in the first section of the course, we had our little wish list of what we want our markets to do, or be, I should say. One of them was we want those markets to be informationally efficient. What that means is that we want the prices now to reflect all known information. Now, if you're going to successfully forecast, what you really need is information that is either widely not known, so it's not widely known, or alternatively, it's not correctly priced in now. That's what you need to forecast. You need either extra information that other people don't have, or B, you have information that other people do have, but you know better how to price that in, and so the prices out there are not reflecting the information that you have. And the fact that they're getting worse tells us, if we accept this explanation, that probably over time the markets have become more informationally efficient. And remember our wish list? We want them to be informationally efficient. This may well be a sign that they're actually improving in that dimension. So we're actually approaching, getting better, getting our markets more in the direction of what we would like them to be. Do you believe me? You look like you don't believe me. Not making any sense to you. Well, the thing is that if the prices now correctly reflect all known information, then that's what we want. There's nothing else out there that is unknown. And so if we want them to be informationally efficient, because without them being informationally efficient, they won't be allocationally efficient. If they're becoming more informationally efficient over time, that means less information out there for someone else to use, then they're also going to at the same time become more allocationally efficient. So that's the idea behind them getting worse is a good thing. Well, no, it's not that less information, it's that there is less information that has not been priced properly. So basically, here's the information. If, say, 15 years ago, this much was priced correctly, we may be over here now. Okay, does that make sense? Does that help you? Good. Right. So here's the dilemma for all investors. Everybody faces this dilemma here, is that all investing is looking into the future. And so this is the problem. Everything we know about lies in the past. Everything we care about lies in the future. But as Master Yoda said, impossible to see the future is. Right. Okay, did you have a question? Sorry?
Just for the one question, if you see the forecast getting worse, does that mean that no matter the poor or none, that they're going to carry more risk in the future? Consider that because what you're doing right now, finance what doing now, you use the forecast, the interest rate, because you said the prediction is getting worse.
Yeah. It means that
we are carrying more risk.
no, it means that the prices now are more reliable. The prices now are more reliable. The prices now are more reliable than they were in the past. Okay, right. One more slide. Basically, what we're saying is that the prices we have now are more reflective of the information than they were in the past. Like you probably didn't see me, I was over there. Like, say there's this much information. And say 15 years ago, that much of the information, here was priced correctly, and there's this stuff here that was not priced correctly. If you had a better model, you could use this stuff. Now, what we're saying is, you maybe this much, from here to here is priced correctly, and maybe there's only this little bit left. And so what we're saying is that as an explanation for why it's become worse in terms of forecasting, is that the prices now better reflect the information that's available.
I know you said that part, which means that you can't get more information out from the data anymore. I say that because all the information from the data is pretty much reflecting the price already. I know, and I get it on that part. But the things right now, so what we do in China is pretty much the focus on that. But what you say is that because the focus is getting worse, does that mean that we have to bear more risk because it's more fragile?
No, because instead of having getting a forecast, what you're saying is that the prices you see in the markets now are closer to being right than they were in the past, and so they are more. The prices you see now are more reliable than they have been in the past. So we have to go outside and see how we've done here.
You're everywhere.
Always.
Oh, you're doing was it the
Mansion 100. Yes, exactly.
I miss your song.
Okay.
Are you still playing songs?
Yes, I do.
Nice to see you.
Likewise. Bye-bye. Oh, that's all right. No problem. If I'm online, I'm online. So, if I'm not online, so if I get to a spot, if I can respond straight away, I will. So, yeah.